Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video, I will be solving the paper 2 exam for October-November 2021, variant 1. So let's get started. Question 1 says, which instrument is most suitable for measuring the thickness of a single sheet of paper that's very small thickness? So 15 centimeter rule, no. Balance, no. Meter rule, no. Basically, these two are the same. Micrometer screw gauge, yes, that is the most precise device. Question 2 says the diagrams show distance time graphs for 4 objects. Which graph represents the object moving with an increasing speed? So speed is the gradient of the distance time graph. So increasing speed means increasing gradient. So a line becoming more vertical. So we choose D. Question 3 says an object has a weight of 6.4 newtons on Earth where the gravitational field strength is 10 newtons per kilogram. Which row states the mass and the weight of the object on the moon where the gravitational field strength is 1.6 newtons per kilogram? So first we calculate the mass. It is equal to the weight divided by the gravity field strength. So we divide 6.4 by 10. In this case, we will get 0.64 kilograms. And then we calculate the weight on the moon by multiplying the mass 0.64 times the new gravitational field strength 1.6. That will give us an answer of 1.024 newtons. So we have 0.64 the mass and approximately 1.0 for the weight on the moon. So we choose A. Question 4 says which substance in the table has the lowest density? We need to divide the mass by the volume. So 1.2 divided by 1, that's 1.2. 1.5 divided by 1, that's 1.5. 1.8 divided by 2, that's 0.6. 2 divided by 2, that's 1. So the one with the lowest density has the lowest number here. So we choose C. Question 5 says a 20-meter long uniform bridge of weight 100 kilonewtons is suspended at each end by pillars as shown. The pillars exert forces T1 and T2 on the ends of the bridge. What are the values of T1 and T2? So if we need to calculate, for example, T2 at first, we need to take the point at T1 to be the pivot, and we say that these forces perform a clockwise moment and only T2 creates an anti-clockwise moment, and we use the concept of moments or principle of moments that says that clockwise moments is equal to anti-clockwise moments if there is no rotation. So we have the 100 kilonewton and the distance from that point. This is a uniform beam, so this distance is half the length of the whole bridge. It's 10 meters, so 100 times 10. That's one of the clockwise moments. And the other force, 24 kilonewtons. It says here that it is 5 meters from the left-hand pillar, so multiplied by the distance 5 is equal to the only force creating an anti-clockwise moment, T2, multiplied by its distance from the pivot here, which is 20 meters. And then we divide by 20 on the other side. That will give an answer for T2 of 56 kilonewtons. So 56 is here. There are no other choices containing 56, so we choose C. And just checking, the downward forces must balance the upward forces. So T1 plus 56 must be equal to 100 plus 24. So if we subtract by 56, we will get an answer of actually 68. So we are sure the choice is C. Question 6 says a spring which obeys Hooke's law has an unstretched length of 10 centimeters. A load of 20 newtons is suspended from the spring. The new length of the spring is 36 centimeters. What is the spring constant K of the spring? K is equal to the force divided by the extension. So we divide the weight or the load, 20 newtons, by the difference in length. So we calculate 36 minus 10. That gives an answer of 0.769, which is approximately 0.77 Newton per centimeter. So we choose B. Question 7 says, what is the relationship between the impulse acting on an object and the change in momentum of the object? They are basically the same thing, so impulse is equal to the change in momentum. That's correct. So we choose A. Question 8 says, electrical energy may be obtained from nuclear fission. In which order is the energy transferred in this process? So nuclear fuel, yes, then reactor and boiler, not generator directly. Then turbines that rotate the generator, because the boiler creates steam and the steam turns the turbines and the turbines in turn rotate the generator, so the answer is D. Question 9 says a motor of power P exerts a force F on an object. The object moves a distance d during the time t that the force acts. Which equation is used to calculate the time t? So power is equal to the energy or the work done divided by time, and work is equal to force multiplied by distance. Then we divide by time. So if we exchange these positions, we have time is equal to force multiplied by distance divided by power. So the answer is B. Question 10 says a scientist uses an electric motor to lift a load through a vertical distance of 2 meters. He then increases the input power to the motor and repeats the experiment. The efficiency of the motor does not change. Which row correctly describes the effect that this has on the useful work done lifting the load and the time taken to lift it? So we are technically moving the same object for the same distance, so the work does not change. So it stays the same, and the time taken, if the power increased, the time will decrease. So this or this, and the common choice is B. Question 11 says 4 containers are filled to the top with the same liquid. The base of each container is circular. Which container has the greatest pressure exerted by the liquid at its base? So pressure in liquids is rho gh. So the density of the liquid is the same, gravity field strength is the same, only the depth affects the pressure. So the deepest liquid will have the greatest pressure, so we choose A. Question 12 says a liquid is evaporating. The liquid is not boiling. Which statement about the liquid is correct at an instant in time? Any molecule can escape? No, not any molecule. So it's not A nor B. Only molecules with enough energy escape, yes. And only from the liquid surface or any part of the liquid, only from the surface. So we choose C. Question 13 says the diagram shows 2 cylinders connected by a narrow tube fitted with a tap. One cylinder contains 80 centimeter cubed of gas at the pressure 2 times 10 to the power 5 Pascal. The other cylinder contains a vacuum. The volume of the evacuated cylinder is 20 centimeter cubed. The tap is open so that the gas can flow to fill both cylinders. The temperature of the gas remains constant. What is the new pressure of the gas? So we can use P1 V1 is equal to P2 V2, or PV is constant. The initial pressure was 2 times 10 to the power of 5 and the initial volume was 80 centimeter cubed. The final pressure is unknown, and the final volume is the volume of the 2 cylinders because the gas will occupy both cylinders. So the total volume will be 100 centimeter cubed. Then we divide by 100 on the other side to get the pressure. This will give an answer of 1.6 times 10 to the power 5 Pascal, so we choose B. Question 14 says an aluminium block has a mass of 200 grams. The specific heat capacity of aluminium is 900 joules per kilogram degrees Celsius. How much energy is needed to increase the temperature of the block from 20 degrees to 110 degrees? So we use energy is equal to the mass times specific heat capacity times change in temperature. So we have the mass in grams and the unit here is kilograms, so we need to convert the mass. That will be 0.200 kilograms times the specific heat capacity 900 times the difference between 110 and 20 degrees. That will give a value of 16,200 joules, so the answer is C. Question 15 is about thermometers, so you can skip this for the new syllabus. It says the diagram shows a liquid and glass thermometer. Which change to the design would result in a more sensitive thermometer? Is it increases the density of the liquid? No. Increasing the diameter of the capillary tube, that will make it less sensitive. Increasing the number of scale markings? No effect. Increasing the volume of the bulb? Yes, that would increase the amount of liquid and the amount of expansion per degree Celsius. So the answer is D. Question 16 says the diagram shows a pan used for cooking food. Which row is correct for the materials used to make the base and the handle of the pan? So for the base of the pan, we need a good thermal conductor or a poor thermal conductor. We need a good thermal conductor to transfer heat quickly to the food inside. And for the handle, we need a poor thermal conductor so the person touching the handle would not get burned. Question 17 says the diagram shows waves in a ripple tank containing water. The waves approach a barrier and pass through the gap in the barrier. The size of the gap is about the same size as the wavelength of the ripples. The gap size is increased, so it's now wider than the wavelength. What happens to the ripple pattern to the right of the barrier? The ripples are closer together. No, the wavelength does not change. The ripples are further apart. No, again, wavelength does not change. The ripples are more curved. No. Diffraction actually decreases, so we choose D, the ripples are less curved. Question 18 says a diagram shows a wave. That's a displacement distance graph. Which row correctly indicates the amplitude and wavelength of the wave? So the amplitude, is it between 1 and 2 or 1 and 3? It's between 1 and 2 because 1 and 3, that's twice the amplitude. The amplitude is from the undisturbed position to the peak, either from 1 to 2 or from 2 to 3. So it's either A or B. And the wavelength is between two similar points. So it's between 4 and 6. Those points are identical. So 4 and 6 here. So the answer is B. Question 19 says two beams of light are both the same color of red. One beam is traveling through air, the other beam is traveling through water. Each beam has a different brightness. Which quantity is the same for both sets of waves? So the only thing that does not change is the frequency. The energy might change, so the amplitude might change. And light travels with different speeds in different media. And if the speed changes and the frequency stays the same, the wavelength also changes. So the answer here is B. Question 20 says a diagram shows a ray of light in air incident on a glass block. Some of the light is refracted and some of the light is reflected. Two angles P and Q are marked on the diagram. Which row gives the angle of incidence and states whether total internal reflection occurs or not? So this is not total reflection because some of the ray was refracted, not reflected. So it's not total internal reflection. And the angle of incidence is between the ray and the normal. So it is the angle Q. So we choose C. Question 21 says the diagram shows a ray of light in glass incident on the surface between the glass and air. What happens if the angle of incidence is made larger than the critical angle for this glass? So moving from the denser medium to a less dense medium with an angle larger than the critical, that will cause total internal reflection. So the angle of refraction becomes 90 degrees. No, there is no refraction. There is a refracted ray. No. This is a refracted ray only, no reflected ray only. There is no ray reflected. There is only a ray reflected inside the glass. Yes, that's total internal reflection. So the answer is D. Question 22 says the sun emits infrared radiation and light. Light from the sun reaches the earth in 8 minutes. Which row gives correct information about infrared radiation? For wavelength, is it longer than light or shorter than light? It is longer than light. And for the time taken for infrared to reach the earth, all electromagnetic waves travel with the same speed in space or vacuum, so it will take the same time, 8 minutes. So the common choice here is A. Question 23 says which list shows regions of electromagnetic spectrum in order of increasing frequency? So for increasing frequency, the highest frequency of electromagnetic radiation is on the gamma rays side. So we have X-rays at the end here and no gamma. So X-rays in this list will have the highest frequency. And then ultraviolet, visible light, infrared, or X-rays, infrared, visible light, ultraviolet. No, infrared should be at the start because it has a long wavelength, so it has short frequency or low frequency. So we choose C, infrared, visible light, ultraviolet, X-rays. Question 24 says what is ultrasound? Sound waves that are too loud? No. Too high pitched? Yes, that's high frequency to be heard by a human ear. Sound waves that are too low pitched? No. Too quiet? No again. So the answer is B. Question 25 says an uncharged metal sphere is placed on an insulating support. A positively charged rod is brought close to the sphere but does not touch it. How do the charges in the sphere move and what is now the charge on the sphere? So it is still neutral because there was no contact and no transfer of charge or no transfer of electrons. And electrons are the only charged particles that can move inside the material. So positive charges move. That's not accepted, so C and D are rejected. And for neutral, negative charges move to the right, attracted to the positive side, and the total charge is still 0, so the answer is B. Question 26 says, in which circuit is the ammeter measuring the flow of charge through the lamp? So the ammeter should be in series with the lamp, so any parallel connection for the ammeter is rejected, and the answer would be B, the ammeter in series with the cell and the lamp. Question 27 says a lamp is connected to a cell. Which circuit diagram shows the direction of the conventional current I and also the direction of flow of electrons E? So electrons are repelled from the negative side and attracted to the positive side. So this is correct, this is not correct, this is correct, this is not correct. And the current is always in the opposite direction to the electron flow. So this is not correct. So the answer is C. The current goes into the negative terminal and the electrons go into the positive terminal. Question 28 says a diagram shows a circuit containing two resistors of resistance 1.0 ohm and 2.0 ohms. A voltmeter is connected across the 1 ohm resistor by connecting P to X. The reading on the voltmeter is 6 volts, so the 1 ohm resistor takes 6 volts of the battery's voltage. P is moved to point Y, so the voltmeter now is connected from here to here, so it reads the voltage across the two resistors, not one of the resistors. What is the new reading on the voltmeter? So basically this is a potential divider circuit or a series circuit where the voltage is proportional to the resistance. So we can use cross multiplication. So if 1 ohm takes 6 volts, how much do 3 ohms, which is the total of 1 and 2 ohms, take out of the voltage? So 3 times 6 divided by 1, that will give us 18 volts. So the answer is D. Question 29 says the graph shows the current voltage relationship for a circuit component X. What happens to the resistance of X? What happens to the temperature of X as the voltage increases? So as voltage increases, the current increases, so the temperature should increase because of the current heating effect. And since the graph is moving away from the voltage axis and resistance is equal to voltage divided by current, this means that the current increases more than the voltage. So actually this whole number will be less. So the resistance will decrease. So the common choice here is B. Question 30 is about logic gates, so you can skip this question for the new syllabus. It says the diagram shows pairs of circuits containing logic gates. In which diagram does the lower circuit of the pair behave differently from the upper circuit? So this is a NOT gate, and whenever a NOR gate or a NAND gate are connected like this with the two inputs joined together, it acts as a NOT gate. So this is the same, so it's not A. And here we have an AND gate, and then we have a NAND gate connected to a NOT gate, which will be converted to AND, so it's not B. For C, we have an OR gate, a NOR gate connected to a NOT gate, so it will be reverted to an OR gate again. So the choice is D here, because we have here an AND gate, and we have a NOR gate with a NOT gate. That will create an OR gate, not an AND gate, so we choose D. Question 31 says, in which circuit do both lamps light? So here in A, the current should go in this way and the diode is connected in reverse. So neither of the lamps will work. No current will flow in the circuit. In B, also the current wants to go in this direction and come back from this direction. And again, the diode is connected in reverse. So no current in the whole circuit. In C, we have the current coming here and will split in these two branches. So the one on the bottom will work normally, and for the one in the middle, it has the diode connected in forward direction, so it will work. So both lamps will work, so the choice here is C. As for D, the diode is connected in reverse for the current trying to move through this lamp. The upper lamp will work normally, but the lower lamp will not work. Question 32 says two resistors with resistances R1 and R2 are connected in parallel. The resistance R1 is greater than the resistance R2. What is the resistance of the parallel combination? Is it less than either R1 or R2, equal to R1, equal to R2, the average or R1 and R2? So in parallel connection, the total resistance is less than the smallest resistance. So it would be less than either R1 or R2. So the answer here is A. Question 33 says the metal cases of electrical appliances are connected to an earth wire. Which statement is not correct? The live wire may become loose and touch the metal case. That can happen if the metal case becomes live. The earth wire conducts current to the ground. That is correct. The earth wire needs to have a high resistance. No, it actually needs a low resistance, so it will create a large current that will blow a fuse. Earthing metal cases helps prevent a person from receiving an electrical shock. Yes, because the current will flow through the earth wire instead of the person. So the answer here is C. Question 34 says, what is the function of a split ring commutator in an electric motor with a single rotating coil? To enable the motor to function with an AC source. No. To reverse the current in the coil once every revolution. Not every revolution, every half revolution. To reverse the current in the coil whenever its plane becomes perpendicular to the magnetic field. That means that the shape of the coil would be like this if the field is horizontal. So when the coil is vertical, actually we need to reverse the direction of the forces because one side of the coil will be moving up. Now we want it to move down, and the opposite for the other side of the coil. So this is actually correct. To reverse the current in the coil whenever its plane is parallel to the field. No. So the answer here is C. Question 35 says, which graph represents an alternating current? So for an alternating current, we need to convert from positive to negative. This is always positive, this is always positive, this is always negative. This has positive and negative. So this is an alternating current. It doesn't have to be a wave-like graph. It just has to reverse direction. Question 36 says the diagram shows a horizontal wire in a magnetic field. The horizontal wire is firmly held at each end. This is not shown, and the wire cannot move. The magnets and holder are on a balance. When there is no current in the wire, the reading on the balance is 0.35 grams. There is a direct current in the wire as shown. What happens to the reading on the balance? So we need first to know the direction of the force on the wire. So we use Fleming's left-hand rule here. So if the magnetic field is to the right from north to south, and we have the current coming out of the page, the force will be upwards. So the force on the wire is upwards. So the magnet is pushing the wire upwards. That would cause a reaction force, according to Newton's third law, on the magnet to be downwards. So the magnet is being pushed down. That would cause the reading on the balance to increase, not decrease, and it will not stay the same. So no change is unacceptable. Smaller is unacceptable. Changing from smaller to larger repeatedly, no. So it will only be larger than 0.35 grams. So the answer here is D. Question 37 says the nucleus of an americium atom contains 146 neutrons and 95 protons. It decays by emitting an alpha particles. How many neutrons and how many protons remain in the nucleus when this form of americium decays? So alpha decay causes the neutron number to decrease by 2 and the proton number also to decrease by 2. So from 146 we have 144, and from 95 we have 93. So the answer here is C. Question 38 says the graph shows how the count rate measured by a radioactive detector placed near a radioactive sample changed with time. So we have here, given that the background count rate is 30 counts per minute, what is the half-life of this sample? First, we take the first reading, and since we have background, this is 530. We need to subtract the background, which is 30. So we have 500. And then we divide that by 2 for one half-life. That will give us an answer of 250. But to move back to the graph with the background, we need to add the background again. So we add 30. This will give us an answer of 280. Now we use this on the graph to get the half-life. So we go to 280. So this is 290, 280. We go to the curve and go down to the x-axis to see the time here. That is 3.4. So the choice here is A. Question 39 says a teacher holds a radioactive source near a detector. The reading on the detector is 320 counts per minute. The detector is switched on again after the source has been removed, and it shows a reading of 20 counts per minute. That's background radiation. What is the counts per minute solely due to the source, and why is there a reading on the detector when there is no radioactive source present? So this is background radiation, and the reading would be 320 minus the background 20. So we get 300. So we choose B. Question 40 says which statement is not correct? Alpha particles are used to detect cracks in metallic structures. No, that would be beta because alpha cannot penetrate metals with any thickness. Beta particles are used in measurement of thickness of paper. Yes, because alpha would be stopped by any thickness of paper, and gamma radiation would not be stopped by paper at all. Gamma rays may be used to treat cancer, yes. Smoke alarms contain a weak source of alpha particles, yes. So the only not correct sentence here is A. So this was the end of the exam. I hope you enjoyed this video and found it useful to you. Keep practicing, and I will see you in another video.